Welcome to Chapter 6, Lesson 5, or E. We're looking at some more properties of logarithms. We're looking at the logarithm of a product. Anytime, so again, this is related to the A plus B multiplying bases kind of rule, where anytime you have two logs that are getting added, you could just multiply their arguments, or if you have a log that has multiple arguments being multiplied, you can separate it out into addition. Similar idea with the log of a quotient. The log of x over y will become the top log minus the bottom log, log base b of x minus the log base b of y. And we've already kind of talked briefly about the logarithm of a power. Again, if you take the log with anything that has an exponent, you're allowed to take that exponent out and turn it into multiplication. And then the final rule that we're looking at today is going to be down here near the end, the change of base property. We have talked about that in the last couple of views, where the log base b of x is really the log of x over the log of b. Again, this is how we get through this with our calculators. So sometimes you might have to expand your logs, and sometimes you might have to, sorry about the audio here, I went to go get my calculator. There we go. Sometimes you might have to expand the logs and make them longer, or you might have to shorten your logs and make them smaller. So right now we're going to work on compression and getting these smaller. So the log base 7 of 10 plus the log base 7 of 5, because that's addition, we can multiply the arguments. This is really the log base 7 of 10 times 5, and 10 times 5 is 50. They didn't ask us to get a decimal, they just asked us to write it as a single log with a single argument, and no multiplication. Log base 3 of 25 minus the log base 3 of 5, so again, because we're subtracting, we can divide our arguments. So we're really looking at the log base 3 of 25 divided by 5, and 25 divided by 5 is really 5. Part C here, again, using our power of a power. Again, this works both forwards and backwards. So we want to take this 3 and bring it up and turn it into an exponent. So we've really got the log base 5 of 2 to the third power. And we'll simplify the argument a little bit. 2 times 2 times 2 is really 8. So we have the log base 5 of 8. And again, so long as your base is the same, you can mix and match these rules. So if I'm adding these two but subtracting this one, we can multiply anything that's got a positive log and then divide by anything that's got a negative log. So we can actually turn this into the log base 2 of 4 times 11 over 2, or the log base 2 of 44 over 2, and then 44 divided by 2 is 22, which is not a nice power of 2, so we'll just leave it there. And again, you can also mix and match your rules about the exponents. So 4 times the log base 5 of 3 minus the log base 5 of 27. So that 4 can become an exponent. I'm also going to simplify my life and say that 27 can also be 3 to the third power for a second. But we're going to get the log base 5 of 3 to the fourth power over 3 to the third power. And now we can subtract the exponents. 4 minus 3 is 3 to the first power, or just 3. So log base 5 of 3. And then finally, our change of base property. Again, this is to help you use your calculator, especially with non-familiar numbers. So the log base 8 of 7 is really the log of 7 divided by the log of 8. And now we go to the calculator and find log of 7 divided by the log of 8. is about 0.936. Even if you got weird numbers, the log base 1.2 of 13.5 can become the log of 13.5, the big number on top, and the log of 1.2, the base number on bottom. And we get 14.275. Again, you are only allowed to put positive numbers into a log. So if we try this one as the log of 3 divided by the log of -2, -2 to no power makes positive 3, really. And if we try that as the log of 3 divided by the log of -2, we're going to get an error message because that's a non-real answer. Again, that's because the log of 3 is actually a real number, but you're not allowed to put in 0 or negative numbers into a log, so there is no solution to this one.